Welcome to Chapter 5, Trig Identities. We'll do this for, I think, the first two sections. 5.1 introduced us to these basic trigs. And I should say Chapter 4 did this. Okay, we learned in Chapter 4, we knew our sine, our cosine, and our tangent. And then we learned the relationship between the sine and the cosecant, the cosine and the secant, the tangent and the cotangent. They're simply reciprocals of each other. We also were introduced in Chapter 4 that tangent is simply the sine over the cosine. Remember, tangent was just our y over our x. Sine was always our y. X was our cosine. And obviously, if tangent is reciprocal to cotangent, all we need to do is flip these, and we have our cotangent. So cotangent is cosine over sine. These are your basic trig identities. We have Pythagorean identities, and there are three here. And these basically come from the Pythagorean theorem. If we squared at x and squared at y, we'd always come to our radius of 1. It's kind of shown in this picture. This is the note sheet I'm sharing with you. And we're going to look to do example 1 here. All right. These other two Pythagorean identities also are true statements based basically from the Pythagorean theorem. So if we look at example 1 here, you've done this before. You've done this on your take-home test or your group test. You've done it on a quiz. We're looking for the sine and the cosine given the tangent and another fact. So in Chapter 4, we did something like this. Oh, tangent's positive. So I can look at it and say, hey, which quadrant is the tangent positive? Well, tangent's positive in the first and in the third. Everything's positive in the first. And we know that a y over an x, both of them would be negative, which would turn into a positive for the third quadrant. Our cosine is greater than 0, which means positive. Cosine, remember, is the x value or the x coordinate. So obviously we have to be in quadrant 1. So we could draw a triangle, just like we have. Okay. And we can label it. Tangent is opposite over adjacent. Use the Pythagorean theorem. 1 squared plus 5 squared. So that's going to be 26. We now know that this is the square root of 26. So the sine of theta here, remember theta is always this acute angle from the origin. Sine is opposite over hypotenuse. So 5 over radical 26. Cosine would be 1 over radical 26. They want us to use not reference triangles, but the Pythagorean identities here. You can see this second one, 1 plus tangent squared equals secant squared. What I'm going to do is I will write the formula I'm using. Why am I using this formula? Well, I'm given a tangent, and I need to find cosine. So if I plug the tangent in here, cosine is the reciprocal to secant, so I'll be able to grab that value. So let me substitute 1 plus tangent is 5, so we got to square it, equals secant squared. So 1 plus 25 is 26. Okay. Obviously, we want to get secant by itself, so we got to square root it. And when you square root secant, you'll get 26. So we know that the cosine is going to be the reciprocal to this. So this is radical 26 over 1, so cosine will be this. That's the same value we got from our triangle. Cosine is the adjacent 1 over the hypotenuse radical 26. Kind of neat and a different way to use our knowledge of our basic trig identities. So there's cosine. Now that we have cosine, we could plug it into this equation and solve for sine. And that would look like this. Try to squeeze it in here. So the formula I'm using is cos squared plus sine squared, and that equals 1. So our cosine is 1 over radical 26, but we have to square that, plus sine squared equals 1. So squaring that will give me a 1 over 26 plus sine squared equals 1. If I want to subtract this, I'll have a sine squared equals, now 1 minus 1 over 26. I'm just going to call that 26 over 26. So when I subtract, it's going to be a 25 over 26. To get sine by itself, I have to square root. And when I square root 25, I get a 5, and then a radical 26. Again, if you go back to our original from last chapter, the sine of this triangle is opposite over hypotenuse. Bam, 5 over 26. We'll be doing a few of these examples on our worksheet 5.1.